So, quite a few people fell foul of the exact, but I did say to you before the assessment, make sure you're aware of the fact that I will say exact answers, and if you don't give me exact answers, you lose credit there. You know, you gain some if you, like, obviously, like criterion A is skills and knowledge. So if you show that you understand how to do trigonometry, you gain skills and knowledge. But the higher levels of skills and knowledge is when you can give it an exact form. All right. So write down exact A and B, exact form. Well, the method that I would have used is just to know that if it's a 30 degrees, the triangle that I'm comparing it to is the 1, 2, root 3 one. Okay? We drew it this way round, didn't we? The 30, the 60, the 1, the 2, the root 3. All right? So then it's a case of knowing that, well, if that was 1 and this is now 5, because I know about similar triangles, that's multiplied by 5. So that's multiplied by 5. So this is multiplied by 5. All right? Therefore, A is 5 root 3, exact form, and B is 10. Simple as that. Okay? The other way to have done it is to say, right, I know 5, which is the opposite side. So sine 30 is 5 over B. Okay? So B is 5 divided by sine 30. And I know that sine of 30 is a half. So I would have done B is 5 divided by a half. And 5 divided by a half is 10. And then I could have done however I wanted. I could have put to find A. Or, I could have done it that method. But that seems a bit more kind of overly complicated than just the similar triangle stuff. Any questions on that? Or is that all right? No? Did you put your hand up there? Or? No? Okay, the next one, people struggled with the show how you can calculate. So a lot of people just stated what it was, but only a couple of you actually were able to say. And all I was looking for was basically the same method I just did for the previous one, which is to say, I'm recognizing that this links to the 1 and 2, because the ratio is a half, which means, okay, I was also perfectly happy with, well, if that's multiplied by 3, that's multiplied by 3, we've got similar triangles, and I know that that is 30 degrees, okay? Because sine of 30 is a half, therefore sine of 30 can be anything, so 3 over 6 is also the same thing. So something along those lines. So what I was looking for was some kind of reference to this, but also the fact that it is 3 times as big, or divide by 3, or whatever, yeah? That's what I was looking for, the link between the similar triangles. You can't just write sine 30 is a half, and therefore x is 30, without saying it's the ratio thing, the similar triangle thing, that's what I was looking for. Right? Does that explain to you something why they didn't quite get, it's difficult, you don't get marks, but you get some. Any questions on that? Make sense? So by the way, this is kind of like a criterion C, communication. How are you communicating your ideas? Right? So when you get to reassessment. Whoa, Sienna, do you want to talk? No, let's not do yours. We've only got one lesson. All right. So it's as simple as this is the adjacent side. This is the hypotenuse. So that means I'm using cosine of 20 is equal to adjacent over hypotenuse, so 479 plus whatever x is divided by 900. So if I multiply through by 900, 900 plus 20, and then that's 479 plus x, then I minus that, so I get 900 cos 20 minus 479, not minus from the 20, but that will tell me what x is. Yeah? And I think you get x is 66 points, which does become 367.7, doesn't it?
Negative 22.
I'm just because someone wrote both of those, and I didn't know how that became that, but I guess it was a slip of the pen.
And how did you get 367?
Just a lack of concentration on your answer. It's the slip of the pen, isn't it? It's not. That's what we would call a silly mistake. Yeah.
Silly.
But it didn't cost you because as long as you wrote the correct answer, you know, so that one. All right. So yeah, yes, yeah, no, you were kind of actually everything you did makes sense.
Right?
You just you're squaring. Right. So basically, guys, I think another option was working this side out. So you could do sine of 20 is equal to, right, that over 900. So 900 times sine 20 is that, okay? So let's say I turn that into a number, right? You could then do 479 plus x, okay, squared plus that, whatever you worked out, that squared is equal to 900 squared. Then when you expand this, you get,
That was my plan.
yeah. Which, everything, I think you just made a mistake in that.
Yeah.
You would have eventually got there, but because you overcomplicated it, you got a, you know.
I got a negative length and I didn't even notice. I was like, yep, this is a good number. This is valid. Like, I was like, oh, length can't be negative. I was like, negative 22. And it's right.
All right. This one, I have to admit, when I started writing the answers, I went, oh, this is a bit nasty. So I'm quite surprised that, like, so many people got it right. I'm wondering whether you got it right by accident. So basically, we know it's from negative 0.5 to 0.5, so the centre line is 0, okay? So if we're looking for A, sine or cosine, well, it starts high and comes down, therefore it's a cosine curve, and then we've got bx plus c. Well, because the centre line is 0, we can forget about the plus c, right? The amplitude is 0.5, so we've got 0.5 cos something x. The something is how many go on in 360 degrees. And it's this number that's actually a bit tricky, because from here to here is the length of one wavelength. But what is that? But how can we show that? How can we prove it? Well, we don't. So this is the important thing, right? This is where it's like, that's an assumption you would make, and you would make it and end up correct. But that's not really a very good process to go through. So really, the best way to go through this is to realise that that's the start of, well, let's look at that's the start of a wavelength, yeah? So I go from the middle to the top, back to the middle is half a wavelength, yeah? Down, that's a full wavelength, yeah? If it was a sine. So if I scrap this bit, because that would be sine, and let's say it's a cosine wavelength, how much is that bit? 3/4. So I can say 3/4 of a wavelength is in 90 degrees, which means 1/4 would be in 30. Divide by 3, yeah? Which means if I times that by 4, 1 in 120. So I can show that it is 120, right? That means if one wavelength is in 120 degrees, how many would be in 360? 3. So it's 3x. 0.5 cosine 3x. So that's the way I would go about working out what that is. And that's why that question is a little bit kind of sneaky. All right? But, you know, with these, you'll see me tick the 0.5. You'll see if I ticked the cosine. So you get credit for each bit. All right? So focus on each bit at a time when you're doing it. And now they're stuck in a car. The height of the nail above the ground varies as the wheel turns. It can be modelled by this graph. Right. Go on. What? So again, we've got A something bx plus c. Alright? So the first thing is to decide, is it a cosine or is it a sine? So here's my centre line. So is it a sine or a cosine? Cosine, because it doesn't start on the centre line. So it's definitely a cosine curve. But it does not start from up here. It's reflected in the centre line, which means it's a negative A cosine. Alright? So then we go for what is A? A is the amplitude. So from 30 up to 60, so the amplitude is so negative 30 cosine. B is the number of wavelengths in 360. One full wavelength has happened in 180, so it's 2 x's, and the centre line is plus 30. There you go. Again, tick, 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 3 half. Alright? This is some credit. Okay, now for the how much do you understand? So I'm just going to rewrite it. So I've got negative 30 cosine 2x plus. There's some interesting comments, some good ones, some ones that miss points out, and some that are just a bit, yeah, let's see. So for instance, right, we've got this curve that does this, right? What does the 30 tell me? Does it? Well, let's go for this one. What's this plus 30?
No, the middle of the...
So the plus 30 is the centre, yeah? Alright. Now, I was perfectly happy with people saying that the plus 30, this 30, right, or even this 30 because it's the centre. If you think about a wheel, right, this would where it would be, yeah? So the centre of the wheel would be at 30. This 30 tells me the amplitude. So either 30 could tell me the radius of the wheel. Alright, so the amplitude could be the radius of the wheel. Why do I say could be?
Because you don't know what the nail is on.
Good. Alright? You all assumed that the nail was stuck.
Well, did someone stab the tile with the nail? Because if they
Quite often you'll see, and again, this is that if you're really on it and you're really thinking of everything thoroughly, right? Let's say this is a wheel and that's the tyre. Quite often things get stuck in the sidewall. Because what happens is your wheel is a bit squished and the nail's stuck up like this, and it can equally go into the side of the tyre. But most of all, right, also what could also happen, if that's the top of your tyre, you'll have seen that there are ridges, yeah? Those ridges are holes that go deeper than the edge of the tyre. The nail could equally be stuck in one of those holes, yeah? So I'm incorrect by saying that the thruster or whatever was the diameter of the wheel. That's not a problem at all. I just went, when you stated it, I went, well, maybe. Because for someone that's really thinking thoroughly, it's about, well, it's technically that's where the nail is. All right? We don't actually know where the nail is in the wheel. We can assume that, but we don't know it. All right? This was an interesting one, the 2x. So, it does do 2 full revolutions in what? So what could that tell me? That none of you wrote, I don't think.
It's the 2 rotations I needed to 360.
But what does that mean?
Oh, circumference of the shell.
What's the circumference of the wheel, or where the nail is? 180, yeah? If we're assuming that the nail is on the edge of the toe, which, you probably already know, that one revolution, the circumference of the wheel is 180 centimetres. Yeah? So that's another thing we could state. Right? Why? A couple of you wrote you knew it was going at a constant speed. Why is that wrong? What would the graph look like if you started going faster?
It would keep going.
They're the same.
Why would it be the same?
Because it's not about time, but distance.
Yeah? This is from here, 0 to 180. If the wheel's going faster, unless you're burning rubber at the beginning and your wheel's actually skidding and therefore not rolling, all right, it's going to go exactly the same distance no matter how fast you go, yeah? That's the whole thing of speed, right? The faster you're going, you cover the same distance in less time. But both my axes were centimetres and centimetres. To have a speed, you need centimetres and a time option, yeah? Speed is kilometres per hour, miles per hour, metres per second, all right? I can't know speed if I've only got distance. So that's an important one, right? So I understand why you would put, because you think it's an important one. Anything else we know? Pretty much nothing, right? You can't make anything else out of that. Right? Yeah. And I wrote at the side, didn't I, that a lot of that was completely irrelevant to the question, and therefore you just spent 5 minutes. But you need, that's the kind of thing we have to cut out, because you are time pressure, right, in your assessments. Right, the assumptions thing here got people.
Yeah,
There was actually only one assumption that I was looking for. Everyone made it, but didn't know they were making it.
Good.
That's why I said here, this can be done in the form of a diagram.
It's just wrong, actually. Wait, so what was the assumption?
I'll tell you. Right, because at some point,
So I drew it, but I drew it wrong. So.
right, I'll tell you what the assumption is as we're going through it, because you all had to make an assumption. Right, there's a vagary in this question. And if I was in the room while you were doing this test, I'm pretty sure this question would have become irrelevant and I'd have had to have gone, sorry, I can't answer that. Alright? Because that was the point. Alright? So, you are the pilot of a light aircraft. So I'm going to put my little, that's my plane. Okay? Here is the land. Okay? And you're approaching an airfield. So let's say here's the airfield. So you are going to land. Right, so the plane is going to go from here to here, yeah? Now, yes, some of you wrote assumption. The plane is going to go straight down, straight line, you know, all that kind of stuff. That's fine. You can make those assumptions. All right. Your altitude is 3,050 meters. So that made perfect sense to put that there. You are heading towards the landing strip, which is currently 14 kilometers away. This is where you made your assumption. Where could the 14 kilometers go? We are 14 kilometers away. Or we are 14 kilometers away.
I just put it there automatically because when we did the radar thing, we were like,
Well, I talked about that because when you do it using sonar, it does, but we're not using sonar. Now, either or, if you put 14 there, fine. If you put 14 here, absolutely fine. It doesn't specify in the question. But if you didn't draw a diagram, but everyone did,
that's like the one thing I did.
right? If you, yeah, that's, no one did. No one wrote it, but you all put it on the diagram. The only one, Sam, put it in both places, I think, which caused a bit of an issue for me, right? Because it can't be both. Why can't it be both? Exactly. So either or, it can only be one or the other.
I know.
I know you only used one of them, but your diagram has both of them as 14.
But I have the different colors.
No, they're both in red.
But I put the actual measurement here in the blue.
But you've got the diagonal measured in 14, and you've got a
I'm
horizontal.
saying that that was an assumption.
But you've measured both distances as 14. You've written them on your diagram, have you not?
I put it as an assumption that it would be that way.
But that's not correct then, is it?
No.
As long as we understand, it can't be both.
I knew that it wasn't that. It's just the way I interpreted the question as
But
incorrect.
but your diagram has to be correct. Now you can pick either or, you can't pick both. Alright? Okay, so that was the question, that was the main assumption that I was looking for. What did you pick? Alright? So let's just assume I'm happy I've picked that one. Alright? Then, well, this is where not an assumption but a mistake happens. Alright? Because the question is which angle of depression should you use. So the angle is actually, we look out, okay, and we drop down. So this is the angle of depression. Too many of you put this. All right?
When it says which angle of depression, is there more than one that you're trying to...
No, so imagine you're in a plane, you're flying straight, you don't want to fly towards the ground. I'm in a plane, I've got to make a choice based on my reading, my counters. How should I dip my plane? What angle should I choose? Yeah, well, it's going to be a depression, but how far? How far do I dip my nose? Yeah? So, it's up to you now. There are two options. If you work this one out, you just need to then do 90 degrees minus that to figure this one.
It makes it better if I only did like 10 minutes after the test to know I did it wrong.
The other option is if this is the angle of depression, and I prefer to have one in the triangle. If I know Sam did extended it that way, which works as well, right? You want to make a different triangle, right? But the angle of depression is the same as the angle of elevation from the ground to the plane. But that changes whether you use sine or cosine, right? So if I base it on this one, not this one, now actually it does affect because things don't quite work out with the numbers in the question. So that's why I had to ask you to make clear on your diagram what values you were using because the answer can be different. Slightly, not hugely, but can be slightly. So this one then, I now know the opposite side of this angle, which is the same as the depression, and this is the hypotenuse, so I'm going to use the sine, okay? 3050 divided by
14,000.
14,000.
I did change it to the
Yeah,
thousand.
not 14, because one's in kilometres, one's in metres. Okay? So then we do, the angle is the inverse sine of that. Okay? And we get the angle ends up being about 12 point something. Alright? And depending on what you did, it could I had two options, I think, like 12.3 or 12.7. 29 is 3. 12.29 rounded 12.3 or 12.7, depending on. Yeah. Well, that's it, because this angle,
65.
this angle is about 77 point something. Alright?
Oh, I got that wrong too?
What? Oh, but my final.
Oh,
Yeah, because for that one I got 89.9.
For that one I got
I
33.5.
got 89.7.
24.
Right, we ready?
I'm like so, like, this is like talented how bad
I'm recording, by the way.
Oh. Now we know.
Well, only we're gonna watch.
No, because parents click on it and
What?
Sorry, my little.
So is that the only
your mum might not. And it's also not just your year group, like the M1s, it's all on one channel, you see. So. But you're representing the school. Right, should we move on? Any more questions? Do you understand? So, I said actually to my M2s, because my M2s are doing algebra at the moment, and there's a lot of stuff I've said to them in assessment. I will definitely catch someone out of this. I will definitely, and I said to them yesterday, I was like, I've said to my M5s, some of you will definitely do this. And I got you. But this question, how many of you forgot to do the right angle of depression? Made a big point of it in class. A lot of you did.
I did the math.
Sienna.
Right?
Can we go over the last one, please?
Yeah, I'm getting it.
Oh, I thought that we were ready to go. I thought that we were like.
Skip the
I
part.
was like, can we do the
Got 15
I did
minutes.
not answer this one. I wrote one word on the page.
15
I
minutes.
got it right, but I was
Guys,
sorry.
stop talking then. Can I do a reset? No, you can't. You don't shut up and listen. Right, so this one. Maybe you should make some notes on your paper. What did you fall foul of? I told you to make sure you got the angle of depression in the right place. And I got the majority of you with that question. All right? It sounds like I've done that on purpose just to catch you out. Yes. I did. All right, so you won't do it next time. All right? Not many, but I'm pretty sure at least one person they've picked the wrong sine or cosine or something. You know? But yeah. All right. This, like the question, it's a hard question. This was kind of like the level 8 question, especially because I said make it the exact length. Again, that wasn't. All right. But there needs to be a little bit of understanding of the situation and similar triangles again. So basically, when I did this, actually, let's see what I'm going to do because I need to do the other. All right. So I want to know the length of the ladder, and the length of the ladder is from here to here, right? So I need to figure out any lengths that I know. So if I'm going to block that off, there, makes a little triangle, yeah? What are the lengths of that triangle? Well, one thing I do know is that's a 1. That's 45. That means that is 45. Which if this is 90 means that is also 45. Which means this length is also 1. Which means this length is root 2. Right? Same here. If I make this triangle 45, 45. This is 2. This is 2. This is 2 root 2. Okay? So the length of the entire ladder is 2 root 2's plus another root 2 is 3 root 2. Okay? Purely special triangles.
I wrote that, but then, like, I didn't put 3 root 2. I put.
Yes, you did. Further down in your work, and you wrote 3 root 2.
What?
And then you changed it to a decimal.
I put 4.24, which is 3 root 2.
Have you not written 3 root 2 somewhere on the page? I'm pretty sure I remember in fact.
Mine's there on the page.
Is it you that
It's
did it?
me.
Okay. And you changed it to decimal.
Yes.
One of you, okay.
I had the decimal, so it was like close to.
So it's incorrect if you have it. Yeah.
This is like
I can't read.
Exact length. Again, criterion A, skills and knowledge. If you get what is the equivalent to 3 root 2, you get some credit.
I've done that.
But, you know, if you don't give it the exact form, you lose credit. So if you couldn't deal with exact form, basically you're not going to get 7s and 8s. Alright? So you know that. That was such a big part of this topic that you have to do it. You have to get your head around the exact form, not needing a calculator. Right, so the next one is, well, I kind of, if you knew that that was special triangle, then you would also get that. I redraw my little diagram, and it says, determine the exact length of the second ladder. It got stuck when it was at an angle of 60 degrees with the wall of the 1 metre corridor. So what that's going to look like is this, yeah? So I draw a diagram to help me understand. Right. Again, my advice, I'm a visual person. I like to see a diagram. Doesn't get to me in my, it doesn't sit in my head if I don't have a diagram. I'm going to use the same method as before. So if I cut that, I know this is the 60 degrees. This is still 1. Right? Now if I think about my triangles, yeah, the 60 degrees, the other end is 30. So I can already put in a 30. Okay. The lengths are 1, 2, and root 3. Okay. So the 1. Right. So let's just redraw that with the 60 degrees. So what do I also have? I have this one, which is a. I'm doing the same thing again, aren't I? But it's going to be slightly more difficult. All right? Right. What can I do? How can I work these out? Again, it's the similar triangle stuff, isn't it? So this is root 3 on the special triangle, but what I've actually got is a 1 there. Yeah? So let me make it a bit clearer. So we're referring back to the special triangle. So that's the 60. This is a 2, a 1, and a root 3. So we're using our similar triangles again. How do I go from root 3 to a 1? Divide by root 3. So everything else must be divided by root 3, right? So then this length here must be 2 divided by root 3. Okay with that? Yes, no? Mm-hmm. Just similar triangle. And then if we go for the other end, okay, we still know that's 60, but this time, all right, do it again. So that's root 3, this is 2, this is 1, here's the 60, here's the 60. What do I know? The bottom one is 2, okay? This time it's super easy, right? If that's a 2, and I know that from the diagram, 1 from 2 is, or 1 to 2, you times it by 2. So therefore, 2 times 2 is 4. So that bit is 4. So what is it in total? 4 plus 2 over root 3. And now I'm fine with that. Once, you know, if we were to go into do simplifying with surds, do you remember how to do that? I said to you, rationalise that. So 4 plus 2 root 3 over 3. Now if I wanted to write it as a single fraction, 4 is actually 12 divided by 3 plus 2 root 3 over 3, which all ends up being 12 plus 2 root 3 over 3. But, as I said, that's fine for a start, because we're not simplifying surds for this question at the moment. Does that make sense? Just similar triangles, using the special triangles? That kind of question, this question here, only works because of the angles they give you, 45, 30, 60. You know, it couldn't do it at a different angle because you need special triangles to do it, right? All right. Any questions on that?